Welcome to Newsmakers. I'm Lisa Oligas. Hands-on education is the focus of immersive learning programs. In the science world, that often means labs. And here at Missouri Southern, the biology lab and research programs take that educational experience and elevate it to professional research levels. So in this edition, we talk in depth with Professor of Biology and Environmental Health, Dr. David Penning. Welcome, Dr. Penning. I want to start with the buildup of this lovely biology lab. When you arrived at MSSU, though, and you did first start teaching here, what was the size of the lab at that time? Because you started mentioning a bucket.
Yeah, it was exactly the size of a 5-gallon bucket. And that's because we didn't have an animal research space. And so I thought it was something that we could probably build here. But it definitely started with traveling with animals in a secured 5-gallon bucket. There's basically a snake-based lid that secures it if you ever put the bucket down, an animal can't get out. So it quite literally started with the volume of 5 gallons and has expanded to the several different labs we have today.
Wow, that's amazing. So I know a lot of your focus is on snakes. Mm-hmm. Why snakes?
Right, so snakes are confusing is probably the 10,000-foot view answer. If you want to think about snakes as a model organism, meaning you use it to study other things, mussels is really the answer. So you and I, we have about 750 mussels. There's some debate about which ones count as unique mussels. Mm-hmm. Pick any snake you've ever seen, one that can fit in the palm of your hand, world's largest anaconda, and they start at about 15,000 mussels.
Wow.
So it's a far more in-depth puzzle to resolve. So you can study mussels in snakes and make some inferences about how they work in humans and other animals.
Yeah. So how did you end up expanding the lab over time, and how many creatures are there part of that lab now?
Yeah, so today we're looking at probably around 200 or so reptiles and amphibians, probably close to 600 or 700 mice and rats. But it started with the research focus that I had. I came from and really felt myself at smaller universities. Mm-hmm. I would have very easily fallen through the cracks if I just started at a big university. And I had a few professors invest in me in some pretty key moments. And I kept my education through knowing I wanted to go back and kind of provide that net. And so upon getting here, it was really teaching focused, but I was determined to make some other really neat stuff happen, and was fortunate enough that one of the first publications that came out when I was here brought the Discovery Channel to campus. And so that really gained a lot of momentum very quickly, where I think people realized not only did that bring a huge PR boom, but also students are involved. Students are working with the Discovery Channel. Students are working with PBS. Students are working with these big locations, and that's a far more in-depth process than just I want some snakes and some aquariums. Yeah. It's we can build out a complex set of learning tools for the students. Cool.
Part of growing a lab seems to be connections with zoos. Mm-hmm. You have a lot of connections with zoos. Talk to us about that and how that relationship is important.
Yeah, so anytime you keep animals, you've got to make sure that you maintain the standards for them. And I think it makes intuitive sense if you're going to have a dog or a cat, what that animal needs. But there's not those enormous, well-established standards for perhaps maybe a group of animals that only has 2 populations in captivity. And so you start to communicate with people about what's working for you. Have you experienced this weird problem with this group of animals? And so you start to increase your protocols for animals, and then other institutions recognize that and then can start to host animals through other locations. If you want to think about animals as something we should preserve, if you have some in captivity and that location gets destroyed, hurricane, fire, earthquake, then that animal is destroyed. So the goal is, can we get ARC programs to other locations where they also have an off-site small population of that animal? And so the idea is, can we create more conservative or conservation programs for animals by spreading them out to other institutions? But zoos are obviously cautious with that to make sure that they're not just giving out rare and endangered animals to people who aren't following appropriate rules.
Well, and there's going to be certain environments that they do better
Absolutely,
than others.
Yeah.
Did you go traveling far distances to get some of these snakes?
Some of them have come far distance. I've certainly traveled far distances, but we've never brought the animals back with us. And so we certainly have different groups of animals that come from the wild, either from stable populations where we can take some, or critically endangered animals that we are hosting that are illegal to capture in the wild now, but now we're serving to try to reproduce them and put them back into populations.
Tell us about some of the countries that they might come from.
So we have, let's see, I'll just go by continent first. So we certainly have North America. We've got Central America. We have South America and probably 6 countries inside of South America. We can transfer over. Nobody's from Europe. It's too cold, and there's really not that many reptiles there.
Okay.
But then we move into Africa. We've got northern and sub-Saharan Africa and South Africa, Australia, Southeast Asia, Asia proper, and we go even so far north as Russia. There's a few very extreme snakes that seem to tolerate that cold, and that itself is just interesting. How is an animal not known for producing their own heat living in an environment that can stay below freezing for 6 or 8 months out of the year?
And that's why they feel cold then. They don't produce their own.
They don't produce their own heat. Yep, they have to use external sources. So they'll stand outside or sit outside on a warm rock or get in water, and they'll accrue heat from the environment. Whereas we produce heat from our metabolism. They're getting it externally. We're producing it internally.
Yeah. So let's talk about turtles, because turtles, you have them. What can we learn from them? And you actually have one with us.
Yes,
so
yeah. So
he's trying to get out. Let's go ahead.
I brought Cleveland with me.
Cleveland.
So Cleveland was a rescue of mine before I was even had my first college degree. So he was this size 20 years ago, and he was living in a cage maybe 30% bigger than his body. And so he's a red-footed tortoise from South America, and so he's probably stunted. He could get bigger, but given his early life, I don't think he's going to grow much more. Yep.
Confined.
Yes, yeah. By basically any care standard, pretty significant neglect. But tortoises and turtles are really tough. And so main things now are just making sure he gets the proper diet, he gets his enrichment activities. For him, that includes like chopping up half a pumpkin, and he can, just rage against it and eat it over the next couple days and things like that.
You've already just told us some interesting things that turtles, I didn't even realize. I mean, scratching a turtle, you think the shell is hard.
Oh, yeah.
They can actually feel?
Yep, there's nerve endings in the back there, yeah. So it's funny to see, it's frustrating to care for, because it means that every corner they take, they cut it a little short, and then every corner they hit, they scratch. So then they just wear down the corners of any room that they're in. And so you have to build almost like a spherical enclosure so that they can't hit corners, because otherwise they will eventually wear through sheetrock. They'll wear through, like, you don't realize what a turtle is basically a sentient rock, and will slowly damage everything. So you end up having to build some pretty custom environments for them.
You mentioned getting him 20 years ago. These are really long-lived creatures, right? So tell us how long he could live. And
yeah. So really weird thing to think about is when an animal lives this long relative to human lifespan, we don't know what old age is yet. So for example, he's probably 37. When you look at estimates of how old they can get, you'll see people say anywhere from 60 to 100. But we've yet to have one get to 100, and then we do anything like a necropsy to see, well, was it healthy or did it die of a disease?
Right.
And so this will take generations of animals, so we don't actually even know the longevity of what these animals can live.
Some of them can live past 100 years.
We have Jonathan, who is one of the largest tortoises, one of the large tortoise species, who I think this year turned 182.
Wow.
And so they are certainly living far beyond what our human lifespan is.
So why is it important for our students to have these real creatures to work with, and what can they learn from?
Right, so why it's important is near and dear to my heart, and I think there's a difference between learning how to do something and doing the something. Oh, he did do it. Yeah, there we go. I told you he was going to probably pee on me. That won't be the first time, buddy. So the real trick here is I can teach you about a turtle, or you can get peed on by a turtle, and there's two very, very different things. And so when you look at biologists, it is far more important that you understand how to do something than read about doing something. So you can learn about what a tortoise is, or you can learn about how to care for a tortoise in what I kind of call like live ammunition science. So I can teach you about how a tortoise works, or I can make you responsible for caring for one. And so that's kind of the big key takeaway here. In the sciences, the degree is the start. So if you did nothing but classes as a wildlife biologist, you are very unlikely to get a career. And it's because they want to see, can you handle how to sedate a raccoon? Can you handle diabetic sugar crashes while you're out in the field? Do you know to watch your teammates to make sure they're chugging water on a 100-degree day? I could tell you on a piece of paper to do that, or we can go do proof of concept outside. And so that's what the animals are here for, is real world live scenario training on how to do their jobs. You
have what's called the Mammal Husbandry Lab, which was born in 2020. So you say students get a cradle to grave experience. Explain what that means.
So when 2020 came around, the real key takeaway there was that everything got expensive. So we had our reptile physiology lab, which means we could order frozen food for our snakes. So you could order thousands of frozen rodents from large manufacturers. everything got expensive, logistical pipelines, all the stuff that we've heard about. And the real answer was that it became almost unsustainable to ship in frozen food. Well, coupled with the reality that we are also training pre-veterinary students. And pre-veterinary students, when they apply to vet school, are evaluated on the different types of animals that they've encountered.
I see.
So you could do 1,000 hours at a vet clinic and nobody's bringing a $4 hamster to the vet. They're going to buy their child a new hamster and hope the child doesn't notice. And so what happens is we have these students logging an insane amount of hours and still having these mass deficits in their exposures. So I basically just merged the two. We need rodents, and we also need experiences for our students. And so we have 2 active veterinarians on staff here. And our students can then make informed decisions about how do you care for that animal. If we have a potential injury, what's the treatment pathway? What's the aspect of their longevity? What's their pain management? And they get to make full decisions. And then we check with a veterinarian and see, would you have killed the patient? What would you have done if you had forgotten this thing? And so they get to see what the consequences are of learning and then doing the next steps, which is real world veterinary work by guided training. And that's a wild difference than here's a slide about how to become a veterinarian.
And then does this then create your food source?
It does, yes, yeah. So we do the training where we manipulate cage enrichment, wheels, toys, different types of food, different types of dietary options. And then at the end, it then produces, it really is a 100% recycle system, because the students are gaining experience on how to care for these animals. And then we have a $0 overhead for feeding the other animals that they then also gain experience on.
Awesome, what a great program. We're gonna take a break, and when we come back, we will talk about the lab's research and publications.
Nowhere else in this area offers anything like this. I grew up in Joplin. I went to Joplin High School, and we had a lot of great opportunities there, but nothing that's like this. And I don't know of anywhere relatively close that you could even get any of this experience as an undergraduate.
If we didn't have this opportunity, there'd be almost no way we'd be getting into any type of competitive grad school. Like, this program is like a ridiculous opportunity for a school this size.
It's really special for me working with these animals. Not only are they beautiful and they all have their own personality, but their physiology is just so interesting. Snakes in general, reptiles in general, are a very underused model organism. This snake here, his name is Joni. He is a eastern king snake. He is actually one of these snakes that my advisor, Dr. Penning, used in his PhD work. He's been in this lab for over 15 years now, and he's one of the animals that I worked with in my research project. And so just to be here and to give these animals a legacy beyond just their life in the lab, but also that, you know, we're using them for good work and we're using them to further science, and they get to live a good life here in the lab where they are cared for, and getting to care for them and take part in that process is really such a blessing. And the work that I'm doing here is going to impact me in my career. It's what's allowed me to be here, and it's what's allowed me to pursue my doctorate.
Just the ability to connect with these creatures and try to educate others on how they are beneficial to have around and how they aren't the villains that people kind of make them out to be.
Welcome back to Newsmakers, where we're learning all about the MSSU biology program and its lab with Dr. David Penning. Welcome back again.
Thank you.
Let's talk about your research. You've done a lot on snake strike speeds and how they consume other snakes, which is kind of surprising to me that they sort of eat their own.
Yes, yeah. It really started just because it was confusing. That's really the answer of I saw something that I couldn't make sense of, and I figured maybe I could answer a few pieces of that puzzle. And so if you just zoom out for what a snake is, it's a garden hose. And somehow one of those is eating another one, which just is confusing. And so I focused on how it is that they're capable of consuming another snake, what the mechanisms are for how they disable it, and to get to catching food, you also have to strike at it. And so I kind of basically just focused my research on snake identifies a potential predator or a potential prey animal, how long till that becomes food or they flee, and all of the measurements in between.
Does strike speed make one more successful than the other? in the snake world?
Real
like,
question
I'm
is,
faster than that.
right, we don't know. If you want a whole PhD, there's a wide open lane for that. What we do know from a little bit of the work that I did with a former student here, who's now at NYU in medical school, is that the quicker the snake is when they strike, the weaker they are when they constrict. So there's a trade-off between your strength and your speed. And we know this in humans. You could be a heavyweight boxer, but you're not fast.
Right.
And you could be a lightweight boxer and you're not as strong. So there is this fundamental trade-off, and we can detect that in snakes as well.
Huh. So you have been featured on PBS and the Discovery Channel, like you mentioned. What is it like to become that go-to expert?
Right.
How does that feel?
5-year-old me would say it feels surreal in that reality of like, what? I've watched those on TV. And then you realize when you actually do it, it's far more the exact same as any other day. And so, like, for example, when we brought the Discovery Channel here, I wasn't supposed to look at the camera, and I needed an eye line outside of the camera, and one of my students randomly walked through the hallway eating pizza. So in that entire documentary, I'm staring at a student of mine named Teddy who's just eating pizza, making eye contact with me off camera, but it looks like all professional and everything, you know. And so you really don't realize that the behind the scenes is far more, it's just a practical day at work. And I just get to let my nerd out and talk about snakes and somehow broadcast that to the world. So that's a pretty good day.
What in your findings was of so much attention to others in the industry, in your industry? What did they find so interesting? What have you discovered?
Right, so the two big ones of a lot of the prior work is one that, and they're almost gee whiz things that when you think about it. And so one is that the dangerous snakes, the venomous snakes, have always been touted as being incredibly fast. And they've never been tested against literally anything else. And so we picked the black rat snake, the western rat snake that you'll find around here. Filmed it, turns out it's just as fast. And so we got to say the most obvious sentence in the world, which is, no food item of a snake cares how they're about to get killed. They don't want to get killed. So if you're hunting mammals, you probably have to be faster than them. And so we broke about a centuries-long paradigm on the venomous snakes are the world's fastest snakes. No, they were the only ones measured.
Wow.
I'm the world's strongest man if I'm the only one measured. That's the idea. And then
Need some comparison.
Yes, you literally need to look at anything else. And then the other was how one snake eats another. And for some reason, one group of snakes called the king snakes are about 20% stronger than other snakes. They have the same amount of muscle, same body size, but for whatever reason can generate about 20% more force, which isn't how muscles work. So it opened up a greater question as to what's going on causing that.
And do you have both of those snakes here?
Yes, we have. Well, we don't have venomous snakes here. We can answer a whole bunch of really interesting questions without the venomous snakes. But I still travel to other universities with our equipment, take our students there and study venomous snakes. But then I can come home knowing that I don't have to worry about a student opening a cage they shouldn't be opening and things like that. And so I get to ask the fun questions and sleep better at night.
Excellent, excellent. Well, part of your lab description, almost mission statement, is the opportunity for publication of quality research exploration. Why is publication an important aspect of what you do with students?
So publications in science are effectively the currency of researchers. So the more publications you have, the more you're communicating with and contributing to your field. So, for example, I got a research fellowship for my PhD, and the reason I was awarded a research fellowship that paid me 70% more was because I had simply submitted a paper for publication. It was swiftly rejected. It was not that good of a paper, but it meant that I was in that arena for publishing. And so anybody can observe something, anybody can write something down, but it's disseminating it through other scientists, validating its experimental design and publishing it that is the gold standard for how research works today.
But as you were mentioning, some things we thought 100 years ago, we find out are not necessarily true today. So it is really important that there's the constant researching, the constant checking of things to see, hey, we know something more, maybe because of new technology.
Yes, absolutely. So I really like to tell students, because the first time a student works with me on research, they realize, boy, we don't know much. And so if you made a column of what you know and a column of how you know it, and you validated the how you know it, you would not have a big list of what you know. Somebody told you it worked that way, you've heard about something that way, and so one of the only ways that we validate truth is through scientific exploration. And so with advanced technology, really great example, the first research project I ever did with a high-speed camera, that camera cost 80 grand.
Oh my gosh.
And was not a very good camera. Today's iPhone has better quality and frame rate than that camera back in the day. And so this opens up doors for social media based research from a phone in your pocket that before required an entirely different grant application and everything else. So as technology advances, we learn at a commensurate rate about new things that was otherwise just priced out of our ability to know things.
Right. So some of the research you've done has taken you and your students out into the field. So talk about that high intensity field research experience, which isn't always comfortable or pleasant, and tell us how students respond to that aspect of that research.
Yeah, I've been pleasantly surprised that they've all done it with a smile. That's been the biggest takeaway. The first day, so we have a site about 30 minutes north of campus in Asbury, Missouri. First day we were out there, it was sub-zero temperatures and 35-mile-an-hour winds. And we're messing with sheet metal and everything else, and you're triple layered, which means you're sweating while freezing. That same field season, we had a day where it was 107 degrees outside. And so we say everybody wants to wear Carhartt until it's time to do things in Carhartt. And that's one of those where, you know, we might be muddy, we might be wet, we might be hot, we might be dry, we might have a headache, we might be hungry, and we still have to perform our jobs. Certainly, I think every human being can relate to having frustrations at work, and 99% of those frustrations are in air conditioning. So add, it's now hot, you're tired, you're sweaty, your feet are wet, and you still have those. So navigating interpersonal relationships and communicating about things towards success, regardless of what's going on, is the really big challenge of field work.
This is observational, so do you usually spend like 24 hours there,
Yes,
48
yeah.
hours there? How long? I mean,
Yeah, so for the last 4 years, thankfully this last year we've dialed in a little bit more efficiency where we can get it done in a day. But prior to 2024, every other weekend for 3 years we were out there. So the first 2 years we'd go out Friday afternoon and we'd get back Sunday afternoon.
Wow.
And so I have a really strong point of pride with that because our students are competing at a national level against other students for jobs. And I can all but guarantee those other students aren't doing every other weekend for 3 years. And so the amount of opportunity that the students get, the amount of work that they're doing, I've been on reference checks where I've had full-time professional biologists say, well, now I'm worried they might be bored at this job. I'm like, oh, no, they'd like to be paid, so I bet they'll be fine, you know. And so
they'll slow down.
Yes, yeah, no, exactly, yeah. They'll go back down to first gear, you know. And so it really has become something that is far greater of an opportunity than I ever thought we'd build in terms of the outdoor field research stuff for our students. Yeah.
Yeah. So tell us about your work in Carthage. You had a finding at Kellogg Lake Park. So tell us about that.
Yeah, so Kellogg Lake is a man-made lake, and anytime you say man-made, you often say naturally, potentially less diverse. And so this is right when COVID hit, and we're walking around, we're walking my dog, and I pick up a snake. I knew what it was. You never pick up a snake if you don't know what it is. And it's called the Graham's crayfish snake. It eats only freshly molted crawdads. So this is as big of a dietary specialist as you can be. And it's in a lake where the grass is mowed to the edge. There's roads around 2/3 of it. This thing's not going to be well known for being a stable ecosystem.
Right.
So we found that. The last record and the only record was from 1906 in the Smithsonian. We now have and have recorded knowledge of a really well supported population in Carthage. Same thing with what's called the stinkpot turtle. Same thing with what's called the diamondback water snake. And the reality is when you get close to political boundaries, scientists stop measuring because that they can't go past the next one. So if I have a permit in Missouri and it walks over to Kansas, I got to talk about a whole new set of governmental policies before I measure it. So anything at geopolitical boundaries is often not measured well. And so we are at really close to a geopolitical boundary, which means we can discover things that science hasn't written down. And that's where we're really coming into play.
So how does that appear in a man-made lake?
Right.
I mean, how did it get there?
Absolutely. It's an if you build it, will they come kind of thing, right?
Yeah.
So it turns out that Spring River runs right along that pond or that lake, and effectively what has happened is it is washed out and washed over. And so we have river-based animals living in a lake. And it's because the lake is basically just a stopover site for these animals that are otherwise in the larger river next to it.
Wow, that's pretty amazing.
Yeah.
So can you then create relationships maybe with other universities to do those crossing state lines that you mentioned is kind of difficult?
Absolutely, yeah. So at that Asbury site, for example, we discovered a salamander there that is, by national standards, the extreme westerly range of it.
Okay.
It's in Missouri, 300 meters, 900 or so feet from Kansas.
Right.
Kansas has never had a record of that animal in their state. if it's 900 feet from the boundary, it's probably in that state.
Yeah.
And so we discussed that at a conference. We talked with Kansas herpetologists, and they now know, be on the lookout in Cherokee County, Kansas, for an animal that we have confirmed in Jasper County, Missouri. And so it allows us to cross-communicate with other locations, and our students at the undergrad level are communicating with state agencies. That's what I mean when I say it's live ammunition work. It's not learning about how you discover the range expansion of a new species. It's being involved in the documentation of a range expansion of a new species.
And how does that feel? What does it feel like when you make a discovery and they get to share that with the science world, and feel free to brag?
Right.
I mean,
well, it's really fun. I mean, like, we've updated, so in Southwest Missouri, we've updated our knowledge of reptiles and amphibians by probably 600 or 700 years when you add up the time between we last knew it was here and we've recently found it. And so when you look at the books that I had as a kid, it has the map of all the animals and where they're found. If you look at a lot of animals, it dips Jasper and Newton County in Missouri. And as weird as that sounds, I'm maybe putting an ink droplet on a map, but we're changing distribution maps in North America because we're walking outside and doing our job. And so that's really neat. And then seeing students publish is also something that I find particularly neat, because they see, like, it's not, a lot of students will come in and say, hey, I have a semester, can I do some research? I'm like, no, this is a 3-year game. And then it might even be after you graduate, you know, and so this might be a 4 or 5 year thing that they stay on, and then they become an author on something that, you know, PhD level students are struggling for as well, and our students are doing it at the undergraduate level. So I take really great pride in the competitiveness and the things that our students can do at a level that you wouldn't expect. That's what I like the most.
I think that is the great part of immersive learning. I mean, here at the TV station, they can produce videos that will get broadcast, and that's sort of being published.
Absolutely,
so
yes.
It's a really neat thing.
Yeah.
Research often takes money.
Yeah.
What's the key to getting grants? Is being published, does that help you?
Yeah, yes, it shows proof of concept, especially at the large scale. So if you want to apply for federal funding like the National Science Foundation or National Institute of Health, you have to show that you have a long history of success with this. Because if they're about to give you a large sum of money, they want to know that a product could happen with it. What can you discover and disseminate about nature with this funding? And the same thing with student grants and small local grants. So luckily, like, for example, Kellogg's Carthage City Friend Group that oversees Kellogg Lake Management, they gave us several $1,000s to study and investigate those animals. And then that's communicating with the public about, why did we not stock the pond that year? Well, because we need to know what's in the pond. Because next year we could stock it, and if we don't know what's in it, we might not be able to stock it again. We need to understand what's in it so we can cycle it appropriately. Or communicating with potential donors about, where's the value in the dollar going, and what is this doing for students. Any time a grant is available, it is arguably a mandate that my students apply for it. Because the goal is, can we make and support ourselves from grants and other funding sources.
That's awesome. Well, you've done great research.
Well, thank you.
And we're going to try and hear from some students as well. And we just really appreciate all you do.
Well,
I think you're really engaging students, and I think they must love it if they
Well,
stick
they
with
keep
it that
coming
long.
back, so I hope so. But yes, thank you very much.
Sounds great. Thank you. And that wraps up this edition of Newsmakers. Thanks to our guest, Dr. David Penning, and thank you for watching.